Okay, gang. So we're looking at a few things this next project. This here is a part that you're going to need to make. This is basically going to be a tool for you as a student. You're going to need this to make your next part. So you can make this whatever dimensions and tolerances you want to hold on it. It's not going to be graded. It's just a tool to utilize to support our parts. We can turn it between centers. So all it is a piece of 1-inch stock. You're going to turn down one side of it and just create a shank so you can hold on to with a shoulder right there. And then on the other side, you're going to be just turning this to a perfect point. So don't lose too much sleep about this. If your dimensions are a little off from what it shows here, it's not the end of the world. It's just going to be a tool that you're going to utilize. And we're actually going to be cutting on this every week. You're going to cut a little bit more and a little bit more and a little bit more off this edge of it. So, and you'll see that when we get out to the machine. So anyways, don't lose a lot of sleep about this piece of it, but I just want to kind of show you a couple pieces of this. So this one here is your simplest part of this next project. Then, if we go on to the shaft, this here is the shaft that we're going to be producing. So I'm going to look at this a little closely here just so you understand what's going on with this. So me as a machinist, when I usually go look at a blueprint for the first time, I'm looking at a few different things. I look at, what kind of material it's made out of. So I'm looking down here and saying, okay, it's 1.25" round, 12L14. So that kind of plays into how I'm going to machine it. If that's made out of aluminum, I might approach it a little differently. If that's made out of stainless steel, I might approach it differently. So I like to really know what kind of material I'm working with. So that's one big element I would look at here. The next piece of it is your tightest tolerance. So if we look around on this part, we can see, all right, we got a 6-inch overall length. When it says 6 inches like that, you actually get to call that a fractional tolerance. So since there's no, it's just a fractional tolerance if it's just straight 6 inches. It's the same if it said 6 1/8. So you get to use fractional, which is plus or minus 1/32. All right, that's pretty gravy. Here we've got 4.56 inches. That's 2 decimal places. We get plus or minus 20. Okay. And then we keep going here, and all these 2 decimal places are all plus or minus 20. Nothing too crazy until we get over here and we see this end. So this 1 inch right here, this is a specified tolerance. And if we look closely here, this is 1 inch in diameter plus 0 minus 2 thousandths. And that's the whole diameter that goes all the way across here. So we need to hold that whole cylinder to that tolerance, which it's easier said than done. There's quite a few variables that go with this that we're going to have to focus on when we get out to the machine. So rather than approaching a part and going and machining it, and maybe you go and make everything else on here, and all of a sudden you go for the last operation, the last thing you want to do is turn that diameter, and then you goof it up. It's a bad idea, because now you've lost, let's say you scrap the part because you didn't hold that tolerance now. Well, now you put all the time into making everything else on here, and you just lost all that time. So when you approach a part like this, for me, and I think most people like to do it this way, is approach the hardest part first. So when we put this in the machine, the first thing we're going to focus on is basically turning this diameter down and getting this to tolerance. If we mess it up, we can go back, and we didn't lose all the time of doing everything else. We only lost the time of what we put into trying to achieve that. Once you do get that portion down, that's the hardest part in the project, then everything else is kind of downhill from there. And that's kind of the best way to approach most parts that you're going to machine. You don't want to put all that time into something and then lose it all. So that's where looking at the material type and then the tolerance and trying to figure out this is going to be the most difficult thing on the part to manufacture. Now, I know you guys are all rookies, so you're figuring out things as you go along here. So you might struggle with some of this other, but realistically, the tolerances on this are not that bad. Plus or minus 20 is pretty sweet all the way through. So you should be able to get everything else to fall in. But this one here, I guarantee is difficult. The other one that's tight on here, quite on this phone. The other thing that's tight on here is also this tolerance here, this little slot. Now this little slot producing this looks like it's a very tight tolerance, and it is, but this is actually pretty easy to achieve. And we can't do this until we have everything else done anyway, because we have to put this in a milling machine to create that slot. So we'll do that towards the end. The idea of this project here is that this piece here fits inside of another mating piece that goes with it. And just to show you, that is going to be this piece. And this one has a very tight tolerance in the ID as well. So on this here, we have +2 -1, or +2 -0. So it's a unilateral tolerance, and this is a little bit bigger than 1 inch so that we can ensure that the shaft will actually slide in here. When it's all said and done, this is a hole that goes all the way through there, and your shaft is going to be able to just barely slide inside of this hole as long as you get your tolerances right. So that's kind of the two pieces and how they fit together, and it's kind of fun making the one part fit inside the other one, just and feeling the shape of and the accuracy that you can put into the shaft and the hub here to get those to fit together so cleanly. So going back, I want to look at the shaft again here, and I just want to show you a few other things on here. Okay, so this is one thing that a lot of people don't understand. We look closely here. This here is a parenthesis tolerance there. That means that this is a reference. And as we get into the part, I can probably explain this a little bit better, but just note that there's no tolerance on this portion of the part. What is critical here is this here. This here we have to hold plus or minus 20 thousandths according to 2 decimal places in the tolerance block. But since this is a reference here, we don't really care where this falls in at, as long as this length comes in and is correct and the overall length is in tolerance. If the overall length is in tolerance and this is in tolerance, we don't really care where this shows up at. And basically your overall length is going to affect how far to move in from this side to achieve this dimension. So if you cut this, or if this is longer, like your overall length comes out at 6 inches 10 thousandths, well then realistically this number is going to measure 700 thousandths, which is acceptable because you get a 32nd on the tolerance here, but you only get 20 thousandths on this. And what we want to do is try to position it in from the face of here to there to make this dimension fall in. And we don't really care where this one falls in at. And I'll talk about that a little bit more as we start cutting things. Otherwise, the other thing with this part here is this part is long enough that we're not going to be able to just machine all of this here and just hold on to the back of it and machine all of this out. So we're going to machine this a little different. We're going to be turning this between centers. That means we're going to put a center in this side of the part and a center in this side of the part, and we're going to turn it between those two. That'll make sure that all of our diameters here are perfectly concentric to the center line of the part, and we really won't have any run out on our diameters as long as we machine them all. They're all going to be concentric to each other because we're going to turn them off centers. And that'll make a little more sense when you see how we go into the machine. So what I'm going to do right now is I'm going to go and I'm going to cut some stock. If I follow the work instructions on this, it tells me to go and cut 1.25 inch diameter stock at 6 1/8 inches long. Realistically, I just need to cut it longer than 6 inches so I can face off this side and face off this side. And if I can do that, I'm going to bring it right to tolerance right away. That's going to be the first thing I do is just face this off and center drill the end of it. Then I'm going to flip it over and face off the other side and center drill the end of that. And when I'm done with that operation, if I have this at 6 inches, plus or minus 1/32, I'm in tolerance and I'm happy. So that will be our next step.